Internet of Things is all devices or stuff which connected to the Internet. Today we have software or devices locally. We use software on our own computer and many electronic devices on our home or office. Suppose there's one day all devices or software are on the Internet. Your own personal software or devices are connected to the Internet. Each time when you want to use some software, you don't need to download it into your own computer and run it. You have an account on the Internet. Sign in your own account and your computer or cell phone, and then you can get control of all your softwares and devices. Internet of Things will make your life easier than before because you get more convenient control of things. We already know that because Internet of Things convenient, so the more and more Internet of Things devices bring more and more Internet of Things data. Here we just say IoT devices and IoT data. And the graph shows that in 2020, over 15 billion IoT objects will be in use. And the more and more data it will cause there are many different types of data, and the data will increase quickly. And so how do we get a good performance of data storage when the number of data is huge? That's a problem. And today we already know we can use cloud to store our files or data. And cloud will help us store IoT data too. There is a short introduction about cloud data storage. Cloud storage is based on virtualized infrastructure. It can help us store IoT data which allow users access easily, and it will protect different types of data. And because most of users already familiar with the cloud, and so it will be easier for the user to store IoT data in the cloud. And there are many different solutions help us to use cloud to store IoT data. And today we will show one IoT cloud framework. And this paper is published by Dr. Jiang and her group in 2014. It was published on IEEE Transactions on Industrial Informatics. And their IoT cloud framework include 4 modules, which are file repository, database module, service module, and resources configuration module. And we can see the architecture of their proposed framework. And the framework can deal with different types of IoT data. And we can see there are many different devices, maybe such as RFID readers, monitors, and maybe there are some different devices that can connect it to the internet, and we can. So it means their data are different. Maybe when we can maybe their data structure and value, accessing methods. They all are different, so we can deal with the different. Here we can maybe choose different type of data. We have different type of data, and then the file repository. It will make use of Hadoop distributed file system to store files, and the database module. It will use NoSQL and the relational database to store structured data, and then the resources configuration module. It will support static and dynamic management. So it's a part of managed data, And data resources and related stories can be configured based on the tenant requirements. And then the storage module, storage management module, storage module is built to generate RESTful service. Yeah. The architecture will deal with different type of IoT data and connected with different IoT devices and services. And so we already know the previous framework is create a database management module that combines and extends multiple database for structured data, and it uses Hadoop distributed file system to store file and for unstructured data. And the IoT-oriented data storage framework, it can apply with many applications, and it supports remote and cross-platform data access. Yeah, and the detail about the approach and the case study about that framework, and in fact, is in that paper. And if you are interested in that part, we can discuss more after presentation. So when we think about the IoT storage optimization, yeah, maybe there are some points we need to consider. And the following 4 points are, are we are the points we need to consider. One is capacity. So there are the data, there are many data and the capacity and the number of objects, different objects, and maybe millions of files and their address. And then third one is protection of different type of data. So different type of data, it means their data structure is different, and maybe their accessing method to the connect to the internet is different. So we need to deal with the different type of data. And the last one is different categories of data. The different categories of data, it means some data they are public, not so important. We can let everyone to see that part of data, but some data they are private, and we hope just we can see that data. Yeah. So it means we need find some different ways to deal with all this data when we optimize the IoT storage. And there are some techniques for maybe we want to share when we consider the data storage optimization. And for the radio, is the H.264. Yeah, we can say it's the next generation radio compression format. And for the image data, JPEG, and is a compression method. And for the text data, LDW is a data compression algorithm. Yeah, we just need to know there are some compression technique for data storage. It can be used in IoT data storage too. And then is the last part about IoT data I want to share is security. When we connected all devices or software in the internet and store our personal data on the internet, we must consider the data security. Different attacks of hardware, platform, or software will happen with IoT data. We may can use the encryption algorithm AES to encrypt our IoT data for us to protect our data. In fact, we have different types of encrypted algorithm which can be used to encrypt IoT data. But here I say we share the AES. That's because its key length can be valuable for the user, and it saves time for the user. It will avoid latency. Yeah. Okay, that's all.